Hello everyone and welcome to the last lecture of digital image processing or remote sensing data. And we know that every good thing has to end one time, so we have reached to the this stage. We have gone through the all types of discussion related with digital image processing of remote sensing data, including different types of enhancement and then interpretations, inferences, modeling, and some indications about integrations and some applications we have also discussed. But as you know that remote sensing data has got enormous possibilities. It is already being used for various applications, starting from your weather monitoring, forecasting, in mineral exploration, in groundwater exploration, in oil exploration. You name it, people are employing remote sensing data, because it is a very powerful tool. But at the same time, you know, there is no universal tool exist. Every tool, every technique has got the limitation. So remote sensing. So in this particular lecture, we will be discussing about the limitations. What are the limitations of remote sensing, and how these limitations will come, will turn in the opportunities in future of digital, because these are all evolving things. So remote sensing, digital image processing, these are all evolving. Every day there are some developments are taking place. Very interestingly, whatever the development which happens in mathematical domain or in computer science domain ultimately also percolates in the field of digital image processing as well as in remote sensing. So any development which has taken place in electronics, maybe in navigation systems or other things, may turn up in improvements in our remote sensing data. Even the development of a high quality battery may increase the life of a remote sensing sensor which is in space. So all kinds of technological developments, indirectly their benefits will come in few years time in remote sensing as well as in digital image processing. So future is very bright in case of remote sensing and digital image processing. However, current limitations are also there because none is universal. So we will see one by one what are the limitations. So let's start first with the limitation, then we will take the future. The limitation here is the image acquisition involves quantization, and here is some problem, because qualitatively when we analyze an image it is fine, but once we go for qualitative analysis then many issues erupt, and thus create a lot of problem in quantitative analysis of remote sensing data. So digital image processing is fine, but when we go, for example, if we go for temperature estimations, now in between there is atmosphere. If atmospheric distortions have not been removed, then the temperature values which we will get through all kinds of analysis may not be a true representative value of that time when the data was acquired. Now this is one issue. Another one is how to compare with whom, because for comparison, in case of temperature values, land surface temperature values which has been derived from satellite data, for comparison we are having a point data, not a spatial data. Whereas suppose it is a NOAA VHR example or MODIS example where 1 pixel is of 1 square kilometer, and whereas your meteorological station is providing data against a point. So when we compare this point data with the spatial data, definitely we are bound to have the differences in the values, and that creates the problem when we go towards the quantitative analysis of remote sensing data through digital image processing steps. So the image acquisition involves the quantization, and this process, that process is often poorly understood, especially when digital image are merely considered as pictures. So this, because the first it is data is collected in analog form and then it is converted into digital. This quantization process may create some limitations of remote sensing data. This is expensive for small areas and project. If I have to work for a very small area, then getting a digital image processing software, satellite image, computer, it becomes very expensive for a small area. But if I am covering on a large area and on regular basis I have to use these techniques, then it is fine. But for a small project, a small area, this is one limitation. Another limitation is expensive for one time, just few times users interpretations. Because again, as mentioned in the previous case, that only if once the technique remote sensing digital image processing has to be employed for a project, only once, then it is really expensive. But if we know that there are regular things, then it is not. So a counter to this one, an alternate is to this one, is that there are people who can do the image analysis, digital image processing, interpretations on your behalf as well. So those facilities are available, but they will charge. So that is why it is said it is expensive for small areas or one-time users. The initial cost, the startup initial cost may be high due to expensive hardware, software, data. Now data, most of the remote sensing data nowadays, especially moderate resolution data, is available free of cost. But if somebody is going for very high spatial resolution data, maybe 30 centimeter, 40 centimeter, then one has to buy. But otherwise, data is not a big issue nowadays, whereas hardware and software will definitely cost to individual users or a establishment. It requires elaborate single purpose equipment. Generally, you have to have all kinds of peripherals along with the digital image processing system, so that one can create good outputs as well. And these might be a single purpose equipment. But nowadays, because of things have developed so much, that only one simple workstation or PC, a good standard digital image processing system can be, software can be installed, and this machine can also be used for various purposes. So this limitation is getting minimized nowadays. But in some few years back, it was a requirement that you should have a separate system for digital image processing. We will go through few more limitations. The limitation is accuracy may be difficult to evaluate, because once, as I have already mentioned, once we go for quantitative things starts becoming complicated. So here the accuracy part, because somebody has done the classification. Now how to assess accuracy, how accurate the classification is after all kinds of digital image processing, and their problem comes, because everything has to be ground checked. And think that if everything has to be ground checked, then there is no use of using remote sensing data. Then let's go in the field, do the mapping, accurate mapping, and prepare a land use map, instead of using satellite image, creating after so much of processing a land use map through satellite images, and then each unit in the field is being checked. So this dilemma is always there, which creates the accuracy issues and problems are there. So once we go for quantitative assessments or accuracy issues, there are always difficulties and challenges and limitations are there. And these accuracy issues comes because of spatial resolution of the data. Sometimes the spatial resolution, you are having a relatively coarser resolution, and then it becomes very difficult to create something very accurate on it, because you know pixel is a unit, and unit means indivisible. We cannot see, we cannot divide a pixel, and there the problems comes. So that if it is a coarse resolution, then you might be having a 80 meter spatial resolution image. So within 80 meter you don't know any differentiation. Everything is same, just one pixel value. So accuracy issues are difficult to evaluate in case of remote sensing digital image processing. And the digital image for digital image processing as input, many times we require the standard image formats. Sometimes what happens that a new satellite has come, the new data is available, but the format is not understandable, or we cannot open that data in a standard image processing softwares, and therefore the problem comes. Then somebody has to program it, and then only one would be able to read that data in that particular image processing software. So these formats, why there is a change, why can we have a universal format, is very simple, because this quantization or radiometric resolution is improving day by day, so the spatial resolution, and this is causing the requirements of new formats to be developed, image format, so that these can be handled very easily. Like for example, instead of having just simple 8-bit data, one can have a sensor like in NovaAVHR, it's 11-bit data. Now on a standard image processing softwares, a NovaAVHR analysis cannot be done because they are designed for 8-bit, and the format of these data is also different. So these formats plays very important role in digital image processing, and one can say that this is also one of the limitations. But because of evolving technologies, these issues will keep coming, keep erupting in due course of time as well. Data may be expensive, especially nowadays. I am talking about high spatial resolution data may not be available. This is another issue, because the archives, I have mentioned earlier also that since 1972 onward you are having archive of Landsat MSS. But the date which you are looking, the season of that particular season you are looking a post monsoon image of a particular area of 1975. Now that may not be available in archive. So non-availability of data can also hamper your analysis. So those issues will keep coming. However, currently lot of free images, as I have been mentioning, are available for our disposals, for making use of them in change detection studies, mainly in change detection studies. Expensive pre-processing is also required. Lot of pre-processing, if you go for quantitative analysis, lot of pre-processing is involved. Radiometric corrections, atmospheric corrections, geometric corrections, all these will cost money. And therefore it is said that these are the limitations with digital image processing, especially for the data which we are going to use for quantitative analysis. And therefore it may require large supporting staff. So for a single project, these things may not be viable, but others can definitely deliver on certain cost. This another problem is, because once the data in digital format, this issue has become larger now, the copyright issue. Because it is easier to copy image from one media to another media. You can download, and you may not give credit to, or may not give in return money or some other credit to those who have created those images. So the misuse of copyright of digital image is now easier than earlier was. This problem has become larger. And for instance, images can be copied from the internet just by clicking mouse a couple of times. Many such data sets are available, and if we don't give the credits those who have provided the data, then it's a violation and breach of copyright, and that creates some legal problems in digital image processing. Now this value of image will get worse. This has not necessarily happened everywhere. This point is that though coarser resolution data is becoming available almost free of cost, but high spatial resolution data is very, very expensive from two angles. One is it is already expensive, and second is that it covers a very small area. And if your area of interest is large, then you have to acquire many scenes with high spatial resolution. As I have discussed in earlier lectures, that higher the spatial resolution, smaller the foot or the width of this path and the swath, and this creates the big problem. So for example, a Landsat MSS may cover a 150 kilometer area in one scene by maybe roughly 150 or 160 kilometer, whereas a Iconos image having 1 meter resolution will cover area of just 11 kilometer. Swath width is roughly that one. So in order to cover the same area of interest by Landsat and here, you have to arrange lot of high resolution data. Lot many scenes are required and therefore it will cost. So this is becoming worse when you go for higher and higher spatial resolution. Of course, if data is available free, then it's a different thing. But as I have mentioned, high spatial resolution data generally is not available free of cost. Only relatively moderate resolution, coarse resolution data is available free. Images held in image banks still have reasonably good prices, in spite of the fact that downloading images through the net is fast and easy. So sometimes while acquiring the data, especially high resolution, creates lot of requirements and processing and so on and so forth. So this can also be considered as one of the limitations of remote sensing data as well as digital image processing. Number of images to handle has increased significantly because we might be looking a larger area to cover, and this may involve a lot of images to be handled, and therefore the mosaicing issues will come. Because if I have to mosaic just 4 scenes, I may not encounter the problems if compared to if I have to mosaic 20 scenes. Because the time difference, the season difference, weather conditions difference may create problems by creating a seamless mosaic. So this becomes another limitations of digital image processing when we are going to cover a large area with high spatial resolution data. Because as the swath width reduces, the temporal resolution also becomes poorer. So that means that a coarse resolution like 1 kilometer resolution satellite sensors are flying almost 2 times in a day over the same part of the earth. But a 1 meter resolution data, the swath is so narrow that the satellite may come after 15 days or 18 days. So this time difference will create maybe changes in the vegetation conditions, maybe in the water body conditions, or maybe in weather conditions. And while making mosaics of such data sets will bring many new issues. So this is another very big limitations of digital image processing. Now these things have become more technical. A non-expert of the field cannot now handle. So it requires a good technical people to take. So this may not be a disadvantage for everyone, but for those who are not aware of all these tools, how to handle them, how data is acquired, how it is processed, then it becomes a limitation for them. Now old professions were left unemployed because they could not learn new skills. As I have been mentioning that the development or evolution of digital image processing and same time remote sensing sensors images is so fast that it is very difficult to keep a track of everything, and therefore the senior people, older people, they find very difficult to catch with the things, and that may be one of the limitations because things are evolving at a very fast rate. Same with the mobile technology. A digital file of a certain size cannot be enlarged with good quality anymore. What it means that if I have acquired the data of a particular spatial resolution, now by no means I can increase the spatial resolution of that image. And if I am looking for some better spatial resolution data, then I have to buy a fresh data set. And that may give you, because that technique doesn't exist anymore. So it is easy to make an image smaller by doing subsampling. But I cannot improve the spatial resolution once a digital image has been acquired by a sensor. So that may be also considered as one of the limitations of digital image processing. Now this point has come already indirectly that limitations of digital image processing requires specialized training for analysis of images. Because like in classification, good understanding about that particular technique is required. If somebody doesn't know about fuzzy logic or neural network, then one cannot employ that technique to do a classification. So therefore this technical requirements, specialized training has become essential for performing certain types of digital image processing. Now large scale engineering maps cannot be prepared from satellite data. That means satellite data or digital image, through digital image processing, we cannot substitute the engineering maps. The importance of engineering maps is there. These are the complementary to each other. So the information or the maps, the utility of engineering maps still remains same, except that these maps can be enriched, or in the background we can have a good satellite image which is perfectly registered with the engineering map. But we are not substituting engineering maps with satellite images. So when we go for very large, very detailed engineering maps, then their satellite images probably through digital image processing cannot be employed to full extent. Now the equipment which we go for digital image processing, especially I am talking about the software, are complex and expensive. They cost lot, these standard softwares, and therefore the whole project becomes very expensive. Rely chiefly upon brightness and spectral content and limited spatial resolution. This is also because for everything, most of the time we are using the optical remote sensing data, and it completely depends on reflection, brightness values, and in what part of EM spectrum it is being used. So that thing also. If we think about hyperspectral remote sensing, then spectral constraints are not there, but the data handling is so huge that normal image processing systems cannot be employed, neither hardware nor software. You need a specialized thing for not only the users have to be equipped with new knowledge, but also the hardware, software part. So this thing is there. Frequent use of data from several channels. This can also create some kind of limitations, and that we use the data from different channels, maybe having a different quality, and therefore there might be a problem. This, as I have been saying, that once we go for quantitative analysis of remote sensing data through digital image processing or objective analysis, there might be some limitations are there with these technologies. Now sometimes satellite images are costly if repetitive coverage are required to study the dynamic features, especially high resolution data I am talking. And because if I need a time series data of a small area at a very high spatial resolution, then this option is very, very expensive. Human selects the most appropriate already acquired data, and generally specifying the resolution, calibrate the sensor, determining the date of the data, and specify how the data will be processed. Thus human methods produce errors may be introduced. That a person, though he is very expert, but he may have choices of his own for spatial resolution, for date of the scene, and processing steps. And that at the end of the day, for certain project, that may create some errors, ultimately limitations. So that thing is also there. Now remote sensing instruments often become uncalibrated, resulting in uncalibrated remote sensing data. So that the sensors which are there, which of this the digital data which we are going to use, may give some problem once they become uncalibrated, because they are in space, the sensors are in a space on board of some satellites. Now this calibration cannot be done. Only some image processing tools can be employed to minimize these distortions which are coming from uncalibrated remote sensing data. So that may become a limitation. Sometimes some sensors, though it has been launched, but the data becomes completely useless, because now that to that extent the calibrations cannot be done, and therefore the data might be coming, but it is no use of them. Further limitations of remote sensing or digital image processing has various, that perhaps the greatest limitation is that utility is often oversold. Remote sensing, GIS, computer science and everything has been oversold. Some people think that everything can be solved, all problems can be solved by employing remote sensing and digital image processing. So this is overselling. This is not true in all the cases. Nothing is universal. No technique is universal, and therefore one day or another you would find limitation with each and every tool or technique. So with the remote sensing, so with the digital image processing. So overselling may create problem for remote sensing and digital image processing users as well. It is not a panacea, that is universal remedy that will provide all the information needed for conducting physical, biological or a science. So that kind of that I have been saying that this is not a universal solution for everything. Remote sensing or digital image processing cannot solve. One of the limitations, the large limitation once I have said, that once the data has been acquired, spatial resolution cannot be improved. This is the biggest limitations. If this would have been possible, then only 1 kilometer spatial resolution data would be sufficient, and then by employing different intelligent image processing technique, one could have created the data at 10 meter, 1 meter, 10 centimeter. But this is not possible. So that is one of the limitations. And simply it provides some spatial, spectral and temporal information. Everything cannot come through the remote sensing or digital image processing. What it is providing, these three information. It is providing spatial resolution or spatial information. It is providing spectral information against certain bands of EM spectrum and temporal resolution. Each satellite or sensor is not overpassing every day of the same, depending on the spatial resolution, as I have been mentioning. Coarser the resolution, the temporal resolution is high. And higher the spatial resolution, the temporal resolution becomes poorer. So these are the inverse relation between temporal and spatial resolution can create some problems in different projects. Now expensive word has already come, but sometimes people compare, very senior people, or they can compare that using atlases, paper atlases is much cheaper than going for expensive solution through remote sensing and digital image processing. That is true, but those are the analog things. They are the frozen things. We can't do much with atlases or these paper atlases, but with the remote sensing data, many things can be done. I have shown some examples how the image interpretations, inferences, even to the modeling we can go related with certain problems, issues. So this expensive issue will remain there. You can consider as a limitations, but a comparison has to be in that sense that paper analog things cannot be really truly compared with digital things in that sense. It requires too much data, and that too in digital form. Of course, for digital image processing, everything has to be in digital form. One example I showed that using a map, a paper map, it was scanned, created in a digital format, and then image processing was done, maybe pseudo color transformation and chain detection map was created. But everything has to convert it into digital format. That is the requirement. So one can consider that is limitation, but this is how it has to go. Now computer intensive, of course, because it has to handle the digital data, hence many times can prove expensive, further require big storage. Yeah, storage is a big issue, and one can consider as a limitation, because as we are going towards higher and higher spatial resolution, the storage requirements are increasing exponentially. Not only spatial resolution, but in spectral resolution. Earlier, like in case of Landsat MSS, we had just 4 bands. In case of MODIS, we are having 36 channels. In case of hyperspectral, we are going to have, or already having 256 channels. And this spectral resolution has improved, spatial resolution might be improving or has improved. So the radiometric resolution, instead of having just 8-bit data, now we are having 13-bit data or 24 bits data. And therefore handling of such data with standard image processing systems becomes very big problem, and therefore ultimately it costs. So it becomes expensive. So expensive tag as one of the limitations of digital image processing will always be there, it may become larger and bigger in future. Now limitation, we continue on this, that remote sensing databases are software dependent. I am using suppose ADAS image processing software. ADAS image processing software requires data in one particular image format which they have designed, like IMG format. Now everything has to go, in order to use smoothly, everything has to be converted in that, and that means cost, because it will require more hard disk space, more conversion, more time consuming and other things. So these databases are software dependent, and hence their export and import are very limited. So if I want to use in some say NV software or some other software, sometimes I have to convert from one format to another, and that cost ultimately. So we can consider as one of the limitations of digital image processing. Sometimes it is said that GIS solutions are too slow, because ultimately nowadays we are going for, and the remote sensing data after digital image processing becomes one of the major inputs in GIS based studies or analysis, and there these solutions are expensive and slow as well. Copyright and distribution issues are too complex. This we have already discussed here. Many times output maps results can only be viewed on the computer. This is another limitations, that every time if some new image processing steps have been taken, some beautiful maps are there or images are there on the screen, but when we go for printing, then limitation comes. So everything has to be seen on computer screen, and that may be considered as one of the limitations, because once we go from digital to analog, some limitations will come. So that is one of the limitations of digital image processing. Now we have seen lot of limitations of digital image processing, also some limitations, linked limitations with remote sensing data, one or two limitations with also with the GIS, but now definitely there is a future of digital image processing and remote sensing. So we will end this course with some positive notes, thinking about the future, what is going to happen in near future. The digital image processing will involve new, more advanced, intelligent and automatic remote sensing data analysis systems. This is already there, things are evolving, as I have mentioned earlier, that any development in mathematical domain, computer science, electronics, all will percolate slowly in the digital remote sensing and digital image processing. It is already happening, so will happen in future. So any development in software engineering or in mathematical domain ultimately will benefit the future of digital image processing and remote sensing. With increase in power and sophistication of modern computing, the concept of computation can be extended beyond the present limits. I can tell you that few years back it used to require a lot of time to display an image of 80-meter resolution on a screen, because these techniques of fast image display, and not only techniques but hardware were not available. But now things have become much faster, and the result of this, we are handling now more data. Rather than handling 1 or 2 scenes, we may be handling now 80 scenes. We are mosaicing 80 scenes. Earlier, even mosaicing a 4 scene was very difficult, and maybe in near future, very quickly we would be able to mosaic 800 scenes. So the data storage, data handling, speed, everything is improving. So there is nothing to worry in that sense, that one day the day has not come that, or will not come when we will say now nothing can be done. No, more things can be done. That's the future of remote sensing and digital image processing. It too includes advancement in various digital image processing applications which are already evolving. New applications are coming, like in case of digital image processing, in the image classification I have mentioned that instead of just based on spectral classifications, we are now going for object oriented classifications, and classifications based on the neural network, classification based on the fuzzy logic, or classification or image processing tools which are coming based on the wavelet. One example of image compression based on a weblet like Mr. Sid is one of the examples, that a 50 MB image is being compressed non-destructively into 1 MB image. So that's the development. So similarly in future maybe we may see some more sophisticated, more advanced data compression or digital image processing tools. Due to innovations in digital image processing and other related technology, there will be millions of systems in the world, and their integration and everything will happen. The future trends in remote sensing will be aiming towards various improved sensors. Sensors are also improving because the electronics is improving, so the sensors are improving. And we should be able to see the more spectral channels as we are seeing through in this hyperspectral. But currently there is only one satellite in high spectral and the swath width is very narrow. So therefore the applicability of such sensors data is very limited. But in future I am sure that swath width might increase and we will have a ready availability of hyperspectral data for many applications which we do not know today. And we might be applying remote sensing and digital image processing for those applications which we cannot think even today. Graphics also of the computers are getting much more advanced and much more powerful, both from their handling side through softwares and hardwares. So that is another future. Advanced researches in digital image processing and artificial intelligence will involve voice commands, anticipating the information requirements, translating languages, recognizing and tracking people and happenings. In near real time, the chain detection may be done based on the learnings which systems will do based on the old archival data. So that kind of future of digital image processing is there. So this brings to the end of this particular topic as well as on this digital image processing of remote sensing data course. So thank you very much and enjoy your studies of digital image processing. Thank you very much.